So we can take the coil like this and a bar magnet is like this. It is on this x-axis, okay? So a bar magnet and it is doing SHM along this axis. First option is induced EMF is minimum when the center of the bar magnet crosses the coil. So in this side, if magnet is coming, flux is increasing. At the center, momentarily the flux will not change. And as it goes out again, flux will start changing. So that means option A is correct. Now option B is the frequency of the induced current in the coil is half of the frequency of SHM. So if I write the current, it will be just EMF by resistance, and EMF is d phi B by dt by resistance, okay? And now this is B into A, and area is almost constant. So magnetic field B, it will be proportional to something like dB by dt, correct? And magnetic field is a function of distance. So if it is oscillating like this, suppose a small x, so whatever derivative you will take, for sine it will become cos, for cos it will become sine, for SHM. So that means frequency is not going to change. So that means this is wrong. Induced EMF in the coil will not change with the velocity of the magnet. This is also wrong, because as I increase the velocity, change in magnetic flux will also increase. And EMF will increase, current will increase. So that's why this is also wrong. And the sign of EMF depends on the north pole face of the magnet. So you must remember that if this is your coil and north pole is approaching, so make N here to remember the direction. It will be anti-clockwise. And if south pole is approaching, so suppose this is the coil and south pole is approaching, so make S here to remember the direction. It will be like this. Okay, so obviously direction will change. It can be understood by, if north pole is approaching here, so magnetic field is increasing, because from north pole magnetic field is coming out. So magnetic flux is increasing. So current will flow in such a direction so as to decrease the flux. So for that, current will flow like this to create opposite magnetic field. And if south pole is coming towards this, opposite will happen. So you should know each and every point if you want to answer correct, especially in MSQs. Okay, all components you should know. Next.